States of matter. Matter is any substance which has certain mass and occupy some volume is said to be matter. Matter is any substance which has certain mass and occupies some volume is said to be matter. This matter is made up of a small particles called atoms or molecules. Matter is made up of small tiny particles called atoms or molecules. This matter may exist in three physical states. They are solids, liquids, and gases. Solids, liquids, and gases. This matter is sometimes may visible to our eyes, sometimes it may not visible to our eyes. Whether the matter is visible to our eyes or invisible to our eyes, whether it is in a solid state or in a liquid state or in a gaseous state, it is made up of a small particles, namely atoms or molecules. Atoms are different and molecules is different, but some matter is made up of molecules and some matter, certain matter is made up of atoms. So, the difference between these three physical states is solids. In solids, the atoms or molecules are in a fixed positions and they bind together with strong electrostatic forces of attraction. That's why when matter is in solid state, it will have a fixed shape and fixed volume. That means the shape of the matter or the volume of the matter is not changed. For example, if you take this duster will have a specific shape because it is made up of small particles. There are several molecules are involved in the building of this matter. This is in a solid state. So, here the shape is a fixed shape because the molecules are at a fixed position and they bind together with strong force of attractions. That's why it has a fixed shape and its volume is also a fixed volume. Chalk piece is also a matter in a solid state. This chalk piece will also have a fixed shape. This pen is also a matter. It is in a solid state. So it has a fixed shape. So solids have fixed shape and fixed volume. If matter is in a liquid state, in liquids, because in solid state atoms are bound together like this, closely packed together. So it has a fixed shape and fixed volume. So these molecules may vibrate. Within the place where they are present, they may have some vibrations. But it will not change its position. That's why it will have a fixed shape. In case of liquids, the molecules are bound together with attractive forces, but there are some large gaps between the molecules. So, the molecules may slide into those gaps. That's why the molecules may not have a fixed shape, but they will have a fixed volume. This is solid. This is liquid. And when it is in gaseous state, the molecules are apart from each other and they will not have a fixed shape and fixed volume. That will be the basic difference between atoms, matter when it is in a solid state, liquid state, and in gaseous state. In solid state, matter will have a specific shape and specific volume. If it is in a liquid shape, it has a fixed volume, but it will not have a fixed shape. When it is a gaseous state, it neither have a fixed shape nor fixed volume. For example, if you take 1 liter of milk, this 1 liter milk will have same volume whether it was kept in a packet or transferred into a bottle or transferred into any other container. But in these three cases, the volume of the milk, which is in a liquid state, is 1 liter only. But when you kept it in a bottle, the shape of the milk is in the shape of the bottle. If you kept in the packet, the milk shape is in the packet shape. If you kept in a tumbler or something vessel, it gets the shape of that vessel. The volume of the milk is not going to be changed. But with the case of gases, they will not have a fixed shape or fixed volume, because each gas molecule will behave independently. The influence of one molecule is not on the other molecules, because each molecule is far away from others. So, the volume of the gas is said to be the volume of the container. Suppose if you take 1 liter of a gas, and if you keep it in a 10-liter flask or 10-liter container, in the second stage or in the second case, the volume of the gas is said to be 10 liter. Same amount of gas. But when it kept in 10 liters container, the volume of the gas is said to be 10 liters. Or if it transferred to 20 liters container, the same gas is said to be 20 liters. If it transferred to 30 liters container, the same gas is said to be 30 liters. That is, gaseous molecules will occupy the whole available space. But it is not in the case of solids and liquids, because solids and liquids, there is strong attractive forces are exist in between the molecules that are present in the given matter. But it is not in the case of gases. In gases, each gas molecule behaves independently. It will move randomly in all directions, and it travel with high velocities. It occupies the whole available space. There are large gaps in between the molecules. So, here there is a provision for the gas molecules to occupy the available space, because there is no attractive forces or repulsive forces that exist among the molecules. That's why when the matter is in gaseous state, it has a separate properties. So, we have to study the matter in a separate manner when it was in gaseous state. So, the studying the behavior of these gaseous molecules, that is the behavior of this matter when it is gaseous state, this study is said to be gaseous state or gas laws, because there are so many parameters which influence the volume of the gas and other properties of the gas. Because gas, when matter is in gaseous state, it has certain special characters which were not found in solids and liquids. For example, if you take this was a container. Now here we have a freely moving piston that was arranged here. This was a freely moving piston was arranged that means it can move from upwards and downwards. Now here I kept some gas here. Now first let us know what are the measurable quantities of gas. What are the measurable quantities of gas and how they are related to each other, and what are the changes when we change one property, quantity, and the influence of that quantity on other parameters. The measurable quantities of gas, first of all, are number one is mass. The measurable quantity, the first quantity is mass, and the second quantity or measurable quantity is volume, and third measurable quantity is temperature. Then fourth one is pressure. These are the three measurable quantities of matter when it is in a gaseous state. Matter, we know, this mass, when matter is there, it is made up of small molecules, small particles which we call as molecules. So, the mass of the gas is generally expressed in terms of grams or in terms of moles. Generally, in scientific way, we express the mass in moles only. Number of moles. Number of moles, we already know. In the stoichiometric property, in stoichiometric chemistry, we have already studied about this mole. So, suppose for example, if you take a sample of CO2 gas, the CO2 gas, if it is a CO2 gas, it contains number of molecules and each molecule will have certain mass. But it is very difficult to express the mass of a single gas molecule in grams. So that's why a new unit called as atomic molecular weight was introduced. So this CO2 molecule was 44 times heavier than 1 AMU or 1/12 of C12 isotope. So the molecular weight of CO2 is said to be 44. Molecular weight of CO2 is said to be 44. So if you take CO2 in grams equal to its molecular weight, that is 44 is the molecular weight of CO2. If you take 44 grams of CO2, then it is said to be 1 mole. Then it is said to be 1 mole. 44 grams of CO2 will be equal to 1 mole. That means number of moles is equal to weight of gas by gram molecular weight. Weight of the gas by gram molecular weight will give us number of moles. So for any gas, this is the general formula to calculate its number of moles. So the mass of the gas is generally expressed in number of moles. Number of moles. Now volume. Volume. The space occupied by the gas is said to be its volume. Generally, when matter is in gaseous state, the volume of the gas is said to be the volume of the container because it occupies the whole volume, available volume. So the volume of the container in which the gas was kept is taken as the volume of the gas. Generally, this volume of the gas is expressed in liters or in milliliters. Liters or in milliliters. And this can also be expressed in cubic decimeters also. When cubic decimeter will be equal to 1 liter, or it will be equal to 10 to the power minus 3 cubic meters. You can also express it in cubic meters also. 1 decimeter cube is equal to 1 liter and it will be equal to 10 to the power minus 3 cubic meters. Now, temperature. Generally, the heat content that was present in a matter is said to be, it may be expressed in terms of temperature. The temperature of the gases will be expressed in a special scale called as Kelvin scale. Traditionally, we use centigrade scale and Fahrenheit scale, but in gaseous state, we use Kelvin scale. This Kelvin scale is almost similar in manner of centigrade scale. By adding 273 to centigrade scale, we will get this Kelvin scale. That means, if it is 0 degrees centigrade, 0 degrees centigrade plus 273 will be equal to 273 K. If it is 100 degrees centigrade plus 273, it will be 373 K. So 0 degree centigrade is the melting point of water or ice. 100 degrees centigrade is the boiling point of water. The difference is 100. Even in the Kelvin scale also, the difference between the melting point of ice and the boiling point of water is 100 only. But when you express in Kelvin scale, it will be 273 and 373 respectively. Why we have to add 273? Because there is a relation between the volume and pressure with the temperature with that figure. That is, for example, if you have taken any gas, the volume of the gas, if the volume of the gas at 0 degree centigrade, the volume of the gas at 0 degree centigrade is V0, at constant pressure, if you increase the temperature, at constant pressure, if you increase the temperature, the volume of the gas will also increases. That increase is 1 by 273 earth of its volume at 0 degree centigrade. 1 by 273 earth of its volume at 0 degrees centigrade. So, if 0 degree centigrade volume is V0, then 1 degree centigrade, the volume will be V0 plus V0 by 273. At 100 degree centigrade, the volume of this gas will be V0 plus V0 by 273 into 100. So, by this ratio, the volume will gradually increases. That's why we are adding this 273. We discuss this in detail in the next hour. So, you need not worry about it at first. The temperature in gaseous, when we are studying the gas laws or gaseous state, the temperature of the gas should always be expressed in Kelvin scale only. It's almost equal to centigrade scale, but numerically it differs with centigrade scale by 273. That is, by adding 273 to centigrade scale, you will get that Kelvin value. If it is 0 degree centigrade, 273 K. If it is 1 degree centigrade, 274 K. It is 2 degree centigrade, 2 plus 273, 275 K. If it is 100 degree centigrade, 373 K. Likewise, this temperature will depend upon this Kelvin scale. So, we will discuss it in detail in the next period. So temperature is expressed in Kelvin scale. Now, the fourth property is measurable quantity is pressure. So, pressure is nothing but the force applied by the gas molecules on the walls of the container. We already discussed when the matter is in gaseous state, the molecules are in random motion in all directions. Due to this motion, these molecules may collide with the walls of the container. When they are striking the walls of the container, they are applying some force on it. The force that was applied by the gas molecules on the walls of the container on a unit area in a unit time is said to be pressure. The gas molecules are in random motion in all directions. During this motion, the molecules make collisions on the walls of the container. Due to these collisions, the molecules will apply some force on the walls. The force applied by the gas molecules on the walls of the container on unit area in a unit time is said to be pressure. Pressure is equal to force by volume. Pressure is equal to force by volume is pressure. So the pressure is generally expressed in terms of the force applied by the gas molecules on the walls of the container is said to be pressure. So the apparatus which used to measure this pressure is said to be barometer. The apparatus which used to set to the atmospheric pressure is said to be barometer. So let us study how it functions and how the pressure is expressed. Here in the barometer, we'll take mercury in a cup. You know that mercury is a metal which is in a liquid state. Now we are taking one glass tube of 1 meter length, sorry, not 1 meter, 100 centimeters length, and this is a tube, capillary tube, which closed one side. So it was filled with mercury. The whole tube was filled with mercury. So this mercury tube was taken here and it is keep like this finger, and if you invert this mercury tube on the pool of mercury, this mercury will stand at certain distance. This height of this column, mercury column, is depends upon the pressure exerted by the atmospheric gases. So these atmospheric gases will make downward pressure on the surface of the mercury that was present in this pool. Because of this pressure, this mercury will stand like this. This height of this column is said to be its pressure. In general conditions, in normal conditions, at sea level, the pressure is found to be 76 centimeters. So pressure is expressed in centimeters, 76 centimeters or 760 mmHg. 76 centimeter Hg or 760 mmHg. This 760 centimeter mmHg will be equal to 1 atm, atmosphere. Atm means atmosphere. This will be equal to 1 atmosphere. This will be equal to 1 atmosphere. So pressure may express in centimeters or in atmospheres, or it can also be expressed in torr. It is equal to 760 torr. It is equal to 760 torr. And 1 atmosphere will also equal to 1.013 into 10 to the power 5 pascals. We express pressure in pascals also. And the same pressure can also be expressed in bar. 1 bar is equal to 0.987 atmospheres. 1 bar is equal to 987 atmospheres, or it will be equal to 10 to the power 5 pascals. 10 to the power 5 pascals. These are the units of pressure. Pressure is the force applied by the gas molecules on the walls of the container. We have already discussed that gas molecules are moving in random motion in all directions. When they are moving, they collide with the walls of the container. When they make collisions on the walls of the container, they apply some force on it. The force applied by the gas molecules on a unit area in a unit time is said to be pressure. This pressure is expressed in centimeter Hg or millimeter Hg or in torr or in atmospheres or in pascals or in kilopascals or in bars. And all these units are interrelated like this. 76 centimeters will be equal to 760 mm Hg. That will be equal to 1 atmosphere. And 1 atmosphere will be equal to 1.013 into 10 to the power 5 pascals. And 1 bar will be equal to 0.987 atmospheres, and it will be equal to 10 to the power 5 pascals. These are the units of pressure in which we express. Now, these 4 properties are interrelated with each other. Now, before going to study their relation, now let us observe the special properties of these gases. The special properties of these gases are, gases will occupy the whole available volume. So, the molecules are apart from each other in a large distance. That's why their density is very less when compared to liquids and solids. The density of the gas is very less. And another important property is compressibility. Compressibility means, here we have a sample of gas in a container which will have a freely moving piston. Now, if you push this piston downwards, what happens? This piston will move downwards. When it will move downwards, these atoms will come closer to each other. When they come closer to each other, the density may increase, but number of molecules are not changing and the mass is not changing. But the volume occupied by the gas molecules will gradually increases. The volume occupied by the gas molecules will gradually decreases. So that means if you increase pressure externally, of course, by increasing the external pressure means inside pressure will also be increasing. The volume will decreases. So decreasing of volume is said to be compression. Decreasing of volume of the gases is said to be compression. This compressibility will have maximum for matter when it is in a gaseous state. You will not observe such compression or such extent of compression in liquids and solids. That we call it as a compressibility. And if you go on increasing the pressure and decreasing the temperature, these gases may converted into liquids. That's we call it as liquefaction or condensation. Because of these special characters, and another property is diffusion. The gas molecules will move in will try to occupy the available area. So it will travel from one place to another place. Suppose if anybody is having a scent on for his clothes, just will get that good smell when he enter into the classroom. So that means that perfume which he used is in a gaseous state. The perfume molecules which are in gaseous state will liberate from his body and travel throughout the air and reaches our nose. That's why we are able to identify the smell of that perfume. If it is a bad smell or a good smell. We know we'll get different types of smells. The smell is nothing but the matter which has that odor, bad odor or good odor, is in a gaseous state, and it travels through air and reaches our nose. That's why our nose is able to identify its smell. So that property we call it as a diffusion. Of course, liquid molecules will also have that diffusion, that we call it as osmosis. That's a different task. So here gaseous molecules, that is matter in gaseous state, will have a special characters. That's pressure, abnormal volumes or various variety of volumes, diffusion, compressibility, and all these things. Because of these special characters, these gases are studied separately. And the laws which explains the relationship between these four measurable quantities of gas is said to be gas laws. The important gas laws are: number 1, Boyle's law; number 2, Charles' law; number 3, Avogadro's law; number 4, Graham's law of diffusion; number 5, Dalton's law of partial pressures. These are the important gas laws which we are going to study in the present academic year.